So we were having a discussion on thread. We discussed yesterday what is a thread, how we can create a thread. Then we discussed life cycle of a thread. Then we discussed how to start a thread, thread name. So today we will see some more in detail, in depth. We will go in thread. Okay. So we were discussing. Uh, we have discussed two ways of creating thread, like using runnable interface and using thread class. We discussed pros and cons of these approaches, right? Then we finally had a discussion on thread lifecycle. Okay, now let me just open that application, Eclipse application, and then we will start writing some code and we'll have some hands-on on threads. So this was the example we were working, right? Now when we say let me just copy the code that we have yesterday. So guys, in Eclipse there is a feature called local history. I think we have discussed this earlier, but I'm not really sure. So yesterday in this system, this was the code, this one. I am taking that code back from the history. Okay, so there are two threads, T1 and T2. Okay, and when we say start, so done gets completed before the threads, right? We have seen that yesterday. You can see T1, 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 T2, 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 and somewhere we have done. So basically what is happening, main thread is basically responsible for creating this thread and then starting this thread. When we say start, what happens, threads gets ready for execution. Once thread scheduler picks up a thread, it comes into running state, right? And when it's done, it goes into dead state, otherwise, or we can say stop state. Okay, like the run method is complete. But from this state, it can be go into waiting state that we haven't discussed yet. We'll discuss that to this one tomorrow. Sorry, today itself. Okay. There is one more thing that is important in this area where we are saying running. Thread is running or running state. There can be only one thread at a time. 1 second, guys. So here in running state, at a time there can be only one thread. So like we have multiple threads. When executing in running state, there will be only one thread, other will be in waiting state or in ready state. Okay. So let's say we have created two thread. When we say start, so start, what start does, it makes the thread ready for execution. And now it's up to our thread scheduler. It will pick a thread and start executing that thread. Okay. Now I have a question for you guys. Like when we say start, what it does, it makes the thread ready so that thread can execute. What if I call this run method directly? What will happen in that case? Is there any error, or Are we going to get the functionality of thread in this case? Any idea about this, guys?
We cannot call the run directly. Why? Because the thread must be in the ready state, right, for the running.
Yes. Yes.
So we cannot call the run method directly, right? The thread scheduler will call the run method. Right?
Yes, you can say, but we can call run method directly. But if we can call it directly, then what will happen? It will be a sequential execution. The point is, first this will be completed line 1, then 5, sorry, line 4, 5, 6, then 8, then 9, then 10. So when we say 10, it will print 1 to 100, then it will go here, it will create another object, and then we'll set the name, and then we'll call again run method, and post that it will say done. Getting my point? So it will be a sequential execution.
That means it's a normal like loop thing, right?
Yeah, no, sequential execution, and you can see there is no thread. The thread name we are getting is main. Only one thread is there.
Okay.
Okay, so yes, we can call this run method directly, but we will not achieve the thread functionality. It's simple like other method. For example, we have a class called X, for example, and in this class we have a method called void m. Okay, and we call this method directly with this X object, something like this. X is equals to new X, and then we say X dot m. So it's simply like that. Getting my point? Let me know, guys. Any doubt
Yes,
in
Anuj.
this? So is it
Yes.
clear? We can
Yes,
do
Anuj.
that, but we are not going to get thread functionality in that case. But when we say start, so what start does, start basically creates a thread and calls its run method internally. We are not calling that run method. Who is calling? Start method is calling run method. Okay. If I say run, what will happen in this case? We'll get the thread functionality. You can say thread main completed itself in first three step, we can say. Then we have T1, T1, T2, T2, T1, right? Now let me go back and do one thing.
Actually, Anuj, in this case, the creation of the object means it won't create the thread.
No,
No.
in this case it is simply one thread, or we can say like we are using association. Association means associating an object into another class or into another object. So simply we can say that. Okay, now if I say we don't have run method here in this class, what will happen then?
It will call the super class run method.
Exactly, but there is nothing in that method, so we'll not get anything. Getting my point? I'll show you. So you can see we started with hello, then main, and then done. Nothing else. So where this method, run method definition is coming from its parent. This one, right? And what it says, target, target dot run. What is target? Target is runnable. And what run says? Run is basically empty here, you can see. So nothing to do. Getting my point? Inside run method, what we are doing? We are doing nothing. Okay, let's go back and we'll uh, discuss one more scenario. What if I say implements runnable? Are we able to use that? Implements runnable. If we are going to say this, what will happen in that case? You can see the code is not getting compiled. Why? When we say interface, then the class implementing an interface must implement all the unimplemented method of an interface. Or you know, in an interface there are only unimplemented methods are there in an interface, or we can say all the method inside an interface are abstract. So the class which is basically going to implement an interface have to implement its all methods. Make sense? So we can say like implement runnable, sorry, uh, implement run method or override run method, then it is fine. Or we can do one thing, like we have the code which we have earlier and we just use that one, implements runnable. So when we say runnable, earlier what we were doing, we were saying my thread empty goes to new my thread, and then we were saying empty dot set name. Now you can see we don't have the capability of set name. Why? Because set name method inside thread class, if you guys see here in runnable interface, there is only one method you can see. Okay, so set name method is basically where in thread class.
So if we want to set a name for the thread by using the implement runnable, how can we set the name?
I'll show you, don't worry. Set name, so set name is basically in thread class. Okay, now your question is how we will set thread name when we are using uh, runnable. Okay, so don't worry, I'll show you. So first let me show you, like we have created a thread using runnable interface and we are trying to run it. So you can see it's again sequential execution. Getting my point? There is no concept of thread when we are saying this thread empty goes to new my thread. Even this thread class implements runnable, but what we are getting is there is no thread. This is simply a sequential execution. Let me run it again. You can see we are getting main printed 1, 2, 3, and then till 100, and again main 1, 2 till 100. 100 time for this line 14 and 100 time for line 10. Now the question was how we will set the name. So before setting name, what we need to do is we need to fix it. We want to achieve thread functionality. So what we need to do is we need to use thread class thread t1, let me call it t1 new thread, and in thread class we have a constructor called or which accepts runnable object. So in our case runnable object is empty. Getting my point? We have a thread object created over here, and based on that what we are doing, we are creating a thread which will basically create a thread. This is not thread basically. Who will make it thread? This thread constructor, right? And then we can say empty dot run. And similarly, we can use this for next thread. This same object we can use, and we'll make t2 with this empty, and we'll say t2 dot run, t1 dot run. Okay, guys. Now let me just start it. Mm, what is wrong here now? Still we are getting main. 1 second.
Here start method is not
Oh,
calling, right?
sorry. We are calling run method directly. So let me go first. Back. Yeah, set name won't be here, and we'll say start, and same thing goes here. start start. But you can see what we are getting is start is not found. This is the similar thing like we are getting with set name, because start is not a method of runnable, and we don't have start method over here. For example, if I say start, I'm just creating my own start method. Like Java provide concept of modifying your existing functionality with the help of overriding. You can do that, but in runnable interface there is no start method. I'm just saying we have a method called public void start. So would this start would will be able to call this or make it thread? No, it's simple as sequential method. Let me just show you, right? Getting my point? Or if you are worried like we are not getting anything, so let me just print it in start. So you can see we are getting in start 2 times. Okay. So now the time to make this a thread. So to make it a thread, what we will do, we'll say thread, or let me just do that here in the end. Thread t1 is equals to new thread, and we'll say empty. Okay. And we'll make one more thread t2, and we'll use the same object for that thread. Now if I say t1 dot start, t2 dot start, now we will be able to get that functionality. You can see it here. This time thread we haven't provided any name, so default name would be like thread 0, thread 1. Next thread, suppose we have, will have similar kind of name. Let me just create one, so it will be like thread 2, thread hyphen 2. Let me call it thread 3, and t3 dot start. So you can see thread 2 we have, thread 1 we have, then thread 0 we have. Okay. So Parveena, you got the answer.
Yeah, yes, Anuj.
So if you want to make a thread using Runnable, at the end you need to use thread class like this, or you can just say simply like this. It's similar thing. What is empty? Empty is new my thread. So I'm taking this directly. Getting my point? So we
So
can
in
do
this
that.
case, we can use the set name method also, right? For the thread T1.
Yes, we can, like t1 dot set name worker 1. So I'm saying this thread have a name worker 1, and you can see worker 1 is doing some work. Like worker 1 get a chance to execute, then worker 1 again get a chance after some time. So you can see here, right?
Yeah. Okay.
Okay, now we will see. So any doubts so far, guys? No doubt, I
Clear
believe.
on my side, Anuj.
Okay, fine. Now we'll talk about thread priority. Okay, like we can provide or set priority so that a thread get priority for execution, right? So to set that, what we can do is t1 dot set priority. Okay. So before going that, what we can do is we can say, yeah. So just show us what is the priority of this thread, and let me just take it 10 times. So here, so it will print 1 to 10. Before that, what we are going to display is priority of a thread. So in thread class, we have a method called get priority. So if we are not setting any priority, the default priority would be 5. Priority basically is a number in thread class that I'll show you just after just executing this code. So you can see we are getting 555. So 5 is a normal priority. 0 is, let me just open a thread class. So we have a number called 0 to 10, min priority. So sorry, zero, not 0, it's 1. So min priority is 1, normal priority is 5, and max priority is 5. So now you must be wondering, like, what is min, what is max? If we say priority 1, so generally you people think, like, if we are giving it first preference, then it should be the first one who completes their execution. Are you guys thinking like that?
No, as in this case, it's max priority means it is giving a more priority to that thread.
Yes. So just don't confuse between your, let's say, IEEE rank or any government exam rank. Like the first person who got first rank will be get a chance to select the college first, and then later one who got second rank will get a chance after first person. So this is not like the case here. The number max priority is 10. So for example, if we want to prioritize a text, a thread, what we can do is we can provide it maximum number 10. Between 1 to 10 we can do that. Okay, let me just show you guys. uh, we were working here in this class. Okay, so let me keep it 100 so that we can demonstrate it properly. Now let me show you output, how it is working right now. So we cannot predict the output, like thread 1, worker 1, and in some between somewhere you are getting thread 2, right? So you cannot predict this output, like how this is getting executed or how your thread is getting a chance for execution, because you have only this area, or you can say it's a uh, mm, runway for aeroplane, right? So at this runway, at a time, only one aeroplane can run. So let's think your aeroplane is that thread. Okay. So at a time, only one thread can be here. Not all the thread can run at a time. So basically, when we say multitasking, what happens? There is a small delay which we don't really take care, and we say we are doing multiple tasks at a time. For example, we talked about an example, like you are sipping your tea, you are reading newspaper and talking to someone in between. So you are doing 3 tasks: sipping your tea, reading newspaper, talking to a person, right? So you are taking pause between, like when you take sip, you cannot speak when you are taking a sip, right? At the moment you are sipping your tea, that moment you are not talking to the person, right? Getting my point? So there is a small delay,
Yeah, here the time taken is very
or
less,
we can
right?
say the,
That's why it is like this.
yeah. So the pause you are taking is basically known as, or will be used by other thread, right? So other thread will use that time for their execution. When a thread is taking a pause, the pause in case of this computer, we can say, is less than a millisecond, right? So we don't really get to know like there is a delay or there is a pause between the task we are doing. It's look like it's continuously working, but in real time there is some delay that doesn't come into picture, right? All right, now let me just do one thing. Let me set priority for this worker thread to the highest priority, which is max priority. So we can say thread dot max priority. We are setting max priority to this thread. Like this will get more execution time or more CPU time, we can say, because we are providing thread has max priority. Okay, and one more thing that I'll discuss after execution of this. So you can see your worker completed task at the beginning, like all other thread were waiting at that time, but your thread was able to complete the task, right? So you can see worker is always finishing task before thread 1 and thread 2 getting, even in between thread 1 and 2 get a chance, but you can see here completed by thread 1 because the priority was high. Okay, now if I say um, t2 dot set priority, and let me do one thing. I'm passing 9 here for this. It's a number basically we need to pass, which is basically should be a int, so we can pass this number. Now set thread 2 will get second priority, right? So thread 2 is basically in our case thread 1, right? Let me just show you guys because we haven't provided any name to thread 2. So you must be thinking like thread 2 is at the end in the output. Let me just show the output. So thread 2 getting complete after all the threads getting complete. So this is not the case because thread 1 is basically the thread to whom we have not provided the name. So set 2 is t2 is basically thread hyphen 2. Now let me set name for this thread. T2 t2 dot set name, t2 dot set name, and the name is worker 2. So now you can see worker 2 completed, right? And worker 1 completed, and at the end who is completing? Thread 2, which is basically don't have any name. Getting my point? Or we can name that 2 as well. So what we can do is, let me take this code over the beginning here, and t3 dot set name, and name is worker 3. Okay, so you can see at the end worker 3 is able to complete its task, and somewhere worker 2 before that, and worker 1 before worker 2. Now one more thing that we can try, like for this thread I'm setting the priority as normal priority. So if we are not adding any priority on a thread, default priority would be 5, or we can say normal priority, right? Now what I'm doing is t1 t3 dot set priority. So now the highest priority is going to which thread? Thread 3. And let me just comment this, like this thread having normal priority. So now you can see thread 3 was able to complete its task before all the threads. Thread 3 85 92, 98. Yeah, here is worker thread completing task 100, right? And task 2, where is task worker 2 is completing its task somewhere before worker 1. Yeah, here you can see, right? And post that worker 1 is getting complete because it is having low priority. Getting my point? Now there might be a question in interview like, what if I provide something like this? What will happen in this case? You can see what will happen. Illegal argument exception. The only applicable values are 1 to 10. You can provide when you say set priority. Otherwise, you will get illegal argument exception. Getting my point? Guys, any doubt in this? Or if I say, let's say 0, I'm trying with 0. This is again not a valid number, right? So only allowed number are 1 to 10 for setting priority. Fine, because we are providing a valid priority. And for 1, we can say it's there is a constant in thread class which is basically min, min priority, right? Min and max. You might get some objective question in some test like what are the priority available in thread class. So for this, what they can show you as an option, right guys, like this. And for this, so there might be a chance you get this kind of option in MCQs exam. Getting my point? So make sure it's min priority, max priority, or one more we have is normal priority. Let me just show you again, which is norm priority. Min value is 1, max value is 10, and normal is 5. Any doubt so far, anybody? Please feel free to ask if you guys have any doubt.
And here I have somewhat confused actually.
Yes, tell
While
me.
giving the priorities also,
Mhm.
giving the priority means not completing the thread, right? It's giving some more
No, no,
time for
no.
the thread.
Priority, you can simply say we have one CPU, right?
Yes.
Which is responsible for executing multiple jobs, right? Multiple jobs
Yeah.
mean like in this program itself we are creating 3 jobs, for example, right? So what we are saying, give more time to job 1 or give more time to job 2 or more time to job 3. So we are setting the priority, who will get the more priority, or simply we can say more execution time, or more area, or more time to run on runway, right?
So in this case also all three threads will run, but the high priority thread will run
Will get
with
more chance to execute. So when we say more chance it will get, so then definitely if the task is equal for all the threads, then it will complete obviously before all the threads. But let's say a thread which is basically doing some task, let's say printing number till 1000, right? And one thread is printing till 10 or 20, and one thread is printing again till 20. So what will happen in that case? Even we are providing more time to that thread which is printing 1000 numbers, but then obviously what will happen is, will not say, we cannot say like the thread having highest priority have a bigger responsibility, will complete that in lesser time. Getting my point?
yeah, yes, Anuj.
Yes. So basically priority is to setting up priority of a thread, like how much time you are going to give a particular thread. today I don't have my pen with me. So yeah, I think I got it. 1 second, guys. Yes, so let's take this example. Suppose you are on road, right? From this way, some MLA is coming, right? You know MLA?
Yeah, yes, sir.
And there is some ordinary people. So what will happen in general, you have seen, this will get more chance, or this will get a chance to execute or go first, right? Let's say there is a cop which is basically handling the traffic police is there, so he will give chance to this vehicle or MLA's vehicle to go, like wherever he or she wants to go, right? So this will get a chance, like other people will wait. Getting my point? Or we can say, uh, once this is done, these are open to go. Getting my point? Now let's say from this way CM is coming. So CM has more priority to MLA, so priority will be given to this vehicle, right? Getting my point? Similarly, let's say from here PM is coming. Now PM has more priority than CM or MLA, so this will get a chance first, or will given the priority, right? So this is the concept of priority basically. Any doubt in this? No doubt?
Here,
Okay.
while
Yep.
PM, the thread scheduler will allow first the PM candidate,
PM to go, yes.
not until the complete, right? After some scheduled time, it will allow the CM also.
Yes, yes.
Yeah, okay. Anuj.
Like you are here, right? The cop is here. Let's say this is thread scheduler. Okay. So he's responsible for passing this PM from this point. Like there might be other cop will be here or there or there or somewhere here, right? So this is basically responsible for this area. Getting my point? He will
Yeah, yes,
stop
Anuj.
traffic from all these sides and will allow this vehicle to go. Once they are passed, then it will serve this one, then this one, then this one, right? Okay. Now let's go back and let's discuss a method called sleep. So if we want to pause a thread for a amount of time, what we can do is we can use sleep method. How we can use that? We can say uh, thread dot sleep, and in sleep we need to provide a timestamp, like how many milliseconds you want to sleep. Sleep method throws an exception that is called interrupted exception, so we need to handle it, right? So I have added try catch here. Now if you run this program, you will see there is some delay. Getting my point? So after 1 second it's working, like, or every thread who is entering into this run method is waiting for 1 second, then printing. You can say like that.
Here, which thread will sleep means all the threads or
No. Yes, you can say all the thread. Like, for example, we have 3 thread, right? We have started all 3 threads. Hmm? What will happen when we say t dot start? All 3 thread will sit here in this area. T1, this is ready state, right? We have created 3 thread. T1, then we have created T2, then we have created T3. Okay. When we say T1 dot start, T1 dot T2 dot start, T3 dot start. So what will happen in that case? All these thread will come into ready state. Now thread scheduler come will pick any of these thread. Let's say thread scheduler picks T1, and when it picks a thread, it starts its execution. So T1 will be here. And when we say run a thread or execute a thread, what it does, it start calling the code which we have written inside run method. Inside run method, what we wrote is print the name of current get current thread object and post that, go into the loop and sleep for 1 millisecond. Now T1 came, entered into this run method and sleep for 1 second. 1000 millisecond, right? Now when it was sleeping, thread scheduler is picking another thread, like this is sleeping. So when we say sleep, it will be here in waiting state. T1 will go here when we say sleep. Okay. Now thread scheduler picks T1 or T3 and keeps it here. So it will go here and it will find I have to sleep for a second. So again it will go here. Similarly, thread scheduler will pick T3, let's say. It will go inside run method and will find, okay, I have to sleep for a moment. So it will sleep this. Now the time is complete. The 1 second is over. What will happen? It will again sit into ready state. After 1 second, it will again sit into running state. But before that, what will happen? It was inside run method. So what it will does, it will execute the remaining part of the run method. Getting my point? Like when we say we entered in run method and we say sleep before printing the name of the thread and the number. So when it came back, it will execute this. Any doubt in this? So every thread is going into sleep state or wait state, and after a certain time, it's getting back into running state, right? Any doubt? Sorry. We have another methods as well, like wait. We have one more method which is basically wait, that we will discuss tomorrow. And tomorrow I'll come with one use case like that we can use thread to implement to improve the performance. Like if we are doing with single threaded application, then what will be the time complexity, and if we are doing with thread, what will be the time complexity or time consumed. So we will discuss one scenario tomorrow for thread, and tomorrow we will discuss these methods that are wait, join, yield, and sleep. We have discussed. We'll have more detailed discussion on sleep, wait, join, yield. So basically, in interview, it might get asked what is the difference between join and yield. So we'll see the difference, how they works when we need join and yield method and wait method. Okay, we'll discuss producer and consumer problem. Anybody has any idea about it? Producer, consumer.
Yeah, the producer means it will return some value. Consumer means it will take, but it won't return anything.
Okay. Yeah. Some. Yeah, you are true. Partially, you are. You can say you are true. And there we will discuss deadlock. Who are from CS or IT background or EC background, they know what is deadlock. Any idea about deadlock? No idea.
Have some idea, but not.
So here is the train one. This is the track. From this direction, there is one more train coming. Right. So what will happen? Now track is only one. From both the side, trains are coming. What will happen in this case? This thread. This train is waiting for train 2 to clear the track, and train 2 is waiting for train 1 to clear the track, right? So this is basically called deadlock. You can say in programming, these are two threads and the track is an object. Two thread basically waiting for a single resource. In general, we can take this example of train, or we can say, let's say we have a ladder. There is a person who is trying to climb, and there is one person which is basically drunk, right? And let's say they both are drunk. What they are saying, I'll climb first. This one is saying I'll climb first, and what he is saying, first I'll go down, then only you can come. And they are stuck. Why? Because they no one is ready to step back. So then this condition will be known as deadlock. So in programming, how deadlock can occur when we are using multi-threads, we'll discuss that. Okay.
Yeah, and we have
So
notify method also.
yes, notify we have. So we'll discuss that notify and notify all. We'll discuss those method as well. So wait basically will be used with notify in general and notify all. So we'll see these methods. But I think tomorrow we'll not be able to cover